In this lesson, we will define radioactivity, describe a radioisotope, explain the characteristics of the forms of radiation, and explain how radioactivity involves a change in the nucleus of a radioisotope. Radioactivity is the spontaneous emission of a particle or energy to become more stable. These emissions affect the nucleus and frequently change the number of protons or neutrons. When the number of protons is changed, it changes the identity of the substance. A radioisotope is an isotope that is radioactive. It can also be called a radioactive nuclide or a radioactive isotope. The key feature is that it is an unstable isotope. Remember that isotopes differ because of a different number of neutrons. For example, we can have carbon-12, carbon-13, and carbon-14. They all have the same number of protons because that determines the identity of the element, but they have a different number of neutrons to give a different mass number. There are several types of radiation. The first one we will look at is the alpha particle. Note that an alpha particle is the same thing as a helium atom, so you will see that notation used or the alpha symbol. We have a mass number of 4, which we see in the superscript, and we have a charge of 2, and that is equal to the value in the subscript or the atomic number. A beta particle is the same thing as an electron, so we use the notation 0 over minus 1e, or a beta. Our mass number is 0, and our charge is minus 1. The charge, which is written as the atomic number, is minus 1. A positron is like a positively charged electron. We use the symbol 0, 1 electron, or a beta with a plus sign. Notice that there is no negative sign included because this has a positive charge. So our mass number is 0 and our charge is plus 1. A gamma ray is a way of giving off excess energy. We see that it has no mass and no charge. For its symbol, we use gamma with or without the zeros. A neutron has a mass number of 1 and a charge of 0. You are responsible for knowing the names, symbols, mass number, and charges of these different particles, because we will use these in balancing nuclear equations. The information about penetration power and shielding are there for your reference. Alpha particles have very low penetration power, but when they're in close proximity to something, they can do a lot of damage. Beta and positrons have moderate penetration power and can be stopped with heavy cloth or plastic. Gamma rays and neutrons have very high penetration power and can actually go through lead, concrete, or water. We will see these particles in nuclear reactions. For example, we can have alpha decay, in which case we see alpha particles being emitted, or beta decay, where we see beta particles being emitted.